All right, guys, this is our last unit. We're going to be graphing quadratics. So we've been factoring them and went through all these things. So when we do a table and you get a straight line, everything grows by the same amount if you take a look at what was doing here. So this is by the same ratio, being that these are all increased by 1. But when we increase by 1 here, take a look what happens. These are not growing at the same rate. Okay? So notice we have a turning point. There's a turning point down here. We have where it crosses the x-axis. That's where we have been solving to factor using the quadratic formula or completing the square or factoring or something like that. So compared to each of the x-intercepts to the graph, what do you notice? Well, this has one x-axis crossing, and this has two. Okay? So sometimes we might get them where they're already factored out. Okay, this is factored form. You have two sets of parentheses. So basically what you're doing is you're finding the x-intercepts when that takes place. It says find the solution to the equation by plugging y equals 0, solving for x. So that's what we've been doing with factoring or the quadratic formula completing the square. These points are also called the solutions and are graphed on the x-axis. So notice we set each of these equal to 0. Notice you might get something out front, that's fine. So the line that divides these into two symmetrical halves is called the axis of symmetry, which is basically this line here. It's the line I could fold it over right on top of in order to get there. The highest or lowest point, so this would be the lowest point, is going to be called the vertex. It's also called the turning point on the graph. The x value, plug into the original, and then you can say the vertex is graphed on the y-intercept is graphed on the y-axis. That's where you plug 0 in for your x values, and you get another point. Okay? So let's take a look at this first problem. The x-intercepts, I'm going to be opposite value, negative 2, 0, and positive 4, 0. Notice these values are opposite of that. It's because if I would have done this and solved it and done this and solved it, I would have gotten that. So I have negative 2, 0, which is here, and 4, 0, which is here. Okay, we want to think about what's halfway in between those two values. So I'm going to count in 1, count in 1, count in 1, count in 1. Okay, this right here is our axis of symmetry. Our axis of symmetry is going to be x equals the middle point, the point that's halfway in between negative 2 and 4. The vertex, I'm going to take this 1 and I'm going to plug it in for my x values here and here. So if I get 1 plus 2, that's 3, times 1 minus 4 is negative 3. So my vertex is going to happen at 1, negative 9. So the axis of symmetry takes place, and then I have negative 9 down here. The y-intercept, if we went and took a look at it, the y-intercept would be, if I were to plug in 0 for x, so 0 plus 2 is 2, 0 minus 4 is negative 4, so I get 0, negative 8. 0, negative 8 is down here, and I also have the reflection over here. And then I have my parabola. It looks just like that. Okay? The next example, so my x-intercepts, opposite of this, opposite of that, so negative 3, 0, and 1, 0. So negative 3 zeros here, 1 zeros over here. Okay, let's figure out our axis of symmetry, what's halfway in between them. So another way I could do it is I realized that from negative 3, negative 2, negative 1, 0, and 1, what number is halfway in between? That would be at negative 1. So x equals negative 1. So here's my axis of symmetry. My vertex, I'm going to take my axis of symmetry, plug that in. I'll plug 1 in here, or negative 1 and negative 1 in there. So I have the negative outside. Negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. So that's going to give me positive 4. So 1, positive 4. My y-intercept, I can get that by just plugging 0 in for x. Okay, so I'm going to plug 0 in for x, plug it in here, so I get negative. 0 plus 3 is 3. 0 minus 1 is negative 1. So that's going to give me positive 3. So 0, 3, which is right there. This point over here also reflects out part of it. That becomes my parabola. Notice it opened upside down. It opens up upside down because of that negative out front there. This one, I'm going to take the opposite of this and opposite of that. So I have negative 5, 0, and negative 1, 0. So negative 5, 0 is here. Negative 1, 0 is here. So I have negative 5, negative 4, negative 3, negative 2, negative 1. This is in the middle. So my axis symmetry is that. So I'm going to just plot this. My vertex, I'm going to take that negative 3 and I'm going to plug it into both of my x values. So I have 2 times negative 3 plus 5 is 2. Negative 3 plus 1 is 2. If I multiply that all together, I'm going to wind up with 8. So, and I should have, that should have been a negative there. That should have been a negative 8. So that's down here. Okay, and if I want to find the y-intercept, I'm going to plug 0 into my x's. So I have 2 times 0 plus 5, 0 plus 1. So that's going to give me 10. So 0 comma 10 was way up here. So that means that this point over here also is part of it. And that's what it looks like. Okay, so this next page, what you want to do is you're trying to figure out which graph it matches with. So this one's going to be upside down because I have the negative up front. This one will be upside down because I have negative. This negative here makes it upside down. And this negative here makes it upside down. So you're just trying to match which graph goes with the given equation. So look for the intercepts first and see if you can determine the graph. And then 13, 14, and 15, and 16 will all be done the same way we just did the homework. So give it a good try. We will have a test on this unit next week, and have a great day.